So now we'll consider the second idealized vortex, and this one's actually called the ideal vortex. And it has circular streamlines as before here. Streamlines are in black. But in this case, there is no vorticity except at the origin. And a velocity field that accounts for that is given by u equal to c, some constant, over r. So the angular component of your velocity field, right? So this is u theta u r. The angular component of your velocity field is inversely proportional to your distance from the origin, and there is again no radial component to your velocity field. So if we sketch this, it becomes an infinite at the origin, and then as r goes large, your velocity becomes very small. And if we consider a fluid element in this case, fluid element like we did earlier, what happens is that this fluid element will purely deform, so that A and B will move faster than C and D. So now you're suddenly up here for A and B, and C and D are dragging. So now the whole thing will purely deform. And if you look at a line segment through here, you will realize that this doesn't rotate. So we have pure deformation and no rotation. And if you compute the curl here of u, i.e. the vorticity, you will find that it is 0. So Wz is 0 everywhere except at the origin, at which it is infinite. So our flow here is actually irrotational, except at the origin. If we look at the circulation for this case, u dot ds, we find that it's actually, for any radius r, u is c over r times r d theta, which is just 2 pi c. So it's a constant. So no matter how large a radius you pick here for your circulation, it's always 2 pi c. And that means it's just the circulation that happens at the origin. Let's consider the limit of the origin. So let's take omega z as r goes to 0. So in this case, the limit of r go to 0, 1 over the area, omega z d area. And this is from the definition of vorticity as the limit of circulation over a small area. We have this as the limit of r going to 0, 1 over pi r squared u dot ds. And u dot ds we just calculated as 2 pi c. So it really is just the limit as r goes to 0 of, and now 2c, the pi cancels, over r squared. So that's why we know that at the origin here, our vorticity goes to infinity. Finally, let's consider what's the circulation around a given fluid element A, B, C, D that doesn't include the origin. So if we do, in order to get that, we would have to integrate over all four sides. So we integrate AB plus BC plus CD plus dA u dot ds. And since BC and dA are perpendicular always to start out with to our flow, so in that case BC and dA, here u is perpendicular to ds, so those are 0. So in that case gamma A B C D is simply minus delta theta u theta r at distance r plus delta theta u theta r at r plus delta r, and that is just 0. So as a result, there's no circulation. And we already knew that since omega z is 0.